big tray of it.
Mm.
Very few would ever go.
Mm.
Most of that tray would be left at the end.
Tyler needs a
Yeah, where's Tyler?
in terms of like novel pieces work on the kind of more platonic side of things.
Too busy, I guess.
I don't know what I would be doing.
No, he hasn't been for 3 weeks.
He's
You
done.
needed a cookie.
Because there's
Something left over at the end. I think that's 5.
I remember there was so many.
great spot.
Wow. So was it just too quiet today, rattling around over in the RDS suite by yourself, or?
Pretty much, yeah.
Yeah.
So, I've got
it was the end
2
of
big
22.
things I need to finish up writing-wise by Monday. And I don't have any meetings, fortunately, so I can do that, but after sitting at my desk for a number of hours,
And I
like, you know what?
remembered it as she was playing it, like I vaguely remember that she did it sometimes. She gave like this introduction. She was like, "Oh, okay, good."
Pretty interesting, so.
Mhm.
She was playing it, and it's just like she just like hits keys, basically going all the way down the bottom, and like you're waiting for something else. She gets to the edge of the keyboard, and then just like done. It's like we all sat there on the edge of our seats for like 2 minutes while she just it was awesome. Though. Wait, what happened?
What else are you up to these days?
Great.
Still waiting for work to come down on the scheduling of the chemistry interviews. Lori's been
Yeah, we've been
busting
back
out
and
trying to
forth
figure
on
out how to make that work.
So the challenge is we have a number of things coming up, either with
Just because of lack of time.
our graduation.
And I also like
or the data workflow specialist, sort of.
put a gash in my finger right on the
Yeah,
knuckle.
plus that
So I
LIT,
couldn't like bend it.
I was looking at this very real prospect of having interviews.
All right, welcome everyone to the Tools and Technology Seminar Series. For any of you who've never been here, although most of you have, this is just a venue to discuss tools, technologies, methodologies, sometimes newly developed or currently in development and process, and just to get some feedback on. Also existing tools, technologies, methodologies that may be used in novel ways or just may not be well known to a lot of researchers. So there is a sign-in sheet. We'll send that around in a minute. If people could sign in, that would be great. It helps us with the pizza. And I'm pleased to present our speaker today, Akima George, who is a grad student in DCMB and is part of the Sally Camper Lab.
Hello, good afternoon. Thank you guys so much for coming. So thank you for introducing me. And today I'll be talking about BAMQL, which is a tool that I have been using recently to help with some of my analyses, and I found it to be very useful. So I thought that it would be really cool to introduce it to you guys, to tell you guys about it, so that maybe you guys would probably find it useful in your research as well. So this is a paper that was published last year by these individuals. And what they did was that they were creating a query language for extracting reads from BAM files. And so what are BAM files? Yeah. There are the binary version of alignment mapping files. They contain sequence alignments and whatever corresponding descriptive information for those alignments. And they're also pretty familiar to anyone who has been working with sequence data. And what the authors were seeking to do was to provide an intuitive way to extract relevant reads from BAM files. So here I'm just showing a couple of properties of SAM files and their binary formed BAM files that researchers use to select relevant reads for further analysis. And here they're just showing the different mandatory fields that are located in these SAM files. And also here they have these descriptive, what they call SAM flags. And these are just numbers that have different sorts of information about the qualities of those reads. And what BAMQL queries can do is that they can filter the BAM file and select specific reads based on these and other criteria. So why use BAMQL? Usually when an individual is doing some form of sequence analysis, only a subset of the reads within their file is what's going to be continuing into further analysis. And to have tools to be able to select these reads are what is mostly desired. And so for standard BAM file manipulation tools, they usually have a limited filtering options, and they're not usually that expressive or user-friendly depending on what sort of queries that you're using to select your reads of interest. And also, if you are using the sound flags to do your read selection, there can be a bit of confusion, especially if you are a student who hasn't had much experience with using BAM files, then you'll probably be a little bit confused in how you want to select your reads from using the flags. You can also use general purpose programming languages like Perl or Python to filter your files, but these are usually, you create those pieces of code for that one project that you're working on, and you probably won't be using those specific codes again outside of that current analysis. And when you're doing something else again in the future, you're probably going to have to write something brand new in order to get whatever is relevant for that other project. And also, there's apparently checking disparities between manipulation languages and BAM APIs. So if you are unaware of these different types of disparities, that might have some kind of effect on your future results. And you probably would not know that those things are there if you're not aware of those. And there's also the potential of sound emission due to mismatches that are difficult to detect. So like, again, if as a student, when I first started working with these sequencing files, I was not very much aware of all of the different sorts of caveats or shortcomings that I might have within my own ability of trying to select reads from these BAM files. So before we start talking about the different things that the BAMQL can do, I just wanted to make a note about what it is and what it isn't. So BAMQL is a querying language. So what it is like you have your BAM file, you tell it, give me these sorts of reads, and it'll pull those out for you. That's all it does. So, and you can also use it to subset BAM files. So you can just have your different, so you'll end up with a number of BAM files possessing the reads of interest or disinterest. So what it is not an analysis tool, and you can't get any kind of summarized relevant information from it. So for example, if you wanted to have, like with the SAM tools stats option, it usually tells you different sorts of qualities of the things within your file. This is not going to do that for you. So you're going to need other tools in order to get those sorts of relevant information. So how do we use this situation? So this is the BAMQL query syntax. And what it is, the thing that makes it, makes it the most useful is what they call predicates. And the predicates are what you are using to ask BAMQL to fetch whatever reads you have of interest. And you can also have multiple predicates using logical connectors. And your predicates could be BAM flags or mapping information, depending on what sort of questions that you want to have answered. You can also have a file, a BAMQL file, that contains a list of queries. So if you have no desire to be inputting things one by one through the command line, it can be automated, and you can have a list of things that it can do for you. So here is just a table showing all of the connectives and predicates that the BAMQL situation uses. And it's pretty brief, but it does a whole lot of stuff. So we can go through it, we can cover it all. This is just a link showing the online manual that holds all of this information in greater detail. But we're going to go through it anyways, so you guys can see what it is about too. So for the BAM flags, So these predicates match reads that correspond to specific flags in your BAM files. And you can also do flag number combination queries by combining relevant predicates. And I thought that was actually pretty useful. So here I just reiterate the previous table that I shown before, and this is just showing the different flag numbers and also their slam flag property. And if you look over here at the BAMQL predicates, this is where they're coming out with having it be an intuitive query language, because it's just like kind of similar to regular English. So like, is it paired? Question mark. And it'll just pull out all of the paired reads for you, right? Like, are these the first of the pairs? Is it read one? It'll just pull out all of the read ones for you. So these are, I thought like, this was like absolutely awesome to me when I saw how wonderfully easy and absolutely intuitive that these are. And so I guess like people who are a bit more experienced in using BAM files, they're probably have more knowledge and probably maybe have a more of a preference for using flags. And they also have a predicate where you can use the raw flag number. So if you don't want, so if you have something in your head, like, oh, I'm always used to using the flag numbers, you can also do your queries with those as well. And so for the raw flag numbers, this is a website that I used to use. So this is from Picard. And what it is that you can input whatever flag number for a read, and you hit explain, and it'll tell you about the flag. So if you're interested in knowing what sort of combinations that you can use in order to generate different flags, this is just like an online source that I was using a lot when I was doing my things, but I don't need it anymore now because I have words. So, so the numbers are useless to me now. Well, not useless, but irrelevant. So this is just an example of showing like how you can get the BAM file based on mapped reads. And so like here, if I want the unmapped versions, I just send them the stuff, ask them to give me the unmapped ones. And the output is they give you like what the number of reads accepted and the number of reads rejected. And they have two separate, you don't have to have your outputs, you can just usually ask them a number and they'll tell you how many reads you want. But if you want your results to be piped into an output file, the output files are usually in BAM format. And then you can end up with multiple files containing what sort of relevant reads that you want. Yes, question?
How did you reject more reads than your file contained?
Aha. So this is the number of unmapped reads, and this is the number of mapped reads, including chimeras and supplementary alignments. I'll talk about that a little bit later. Good job. So yeah, so all of your information is in there. And this is kind of like information that you have to have in advance, because like you just asked, I know how many situations I put in there or what is up with these numbers. So you can also figure that out later on in your analyses. Next, forward. So another form of predicates that you can use are the mapping information predicates. And these are just ones that select reads due to whatever desired read attributes that you want. So like, for example, if you want all of the reads on a particular chromosome, you can just do that. You can tell them chromosome, enter whatever value you have there, and it'll pull all of those out for you. One of the caveats for this chromosome function is that if your chromosome is not labeled in this form of format, it's not going to work. So like here, for an example, like they have the numbers and the letters corresponding to each other. But like when I was doing my analysis, that wasn't how my chromosomes were labeled. So when I was trying to pull the chromosomes out, it was crying. So you have to know in advance exactly what situation that you're working with. And also, you can also pull out reads of whatever quality. And here is just a probability value between 0 to 1. And if the probability of error is less than your specified probability, then it'll pull those out. And also, yeah, different ones. that you guys can see here. So like you can get your mate pairs. If here they're asking for split pairs to check if whether or not your paired read is located on another chromosome, and you can use this function to check for chimeric reads. And also, if you have different read groups in your BAM file, you can also just tell them, I want all of the read groups of some volume, and they'll pull them out and place them in a file for you. So I thought that was awesome. And this is just like another one showing how you can get reads based on quality. And here, I just asked some random value, and they pulled them out for me. And like here, you can see I only have one BAM file in output, which is the ones of high quality, and the ones that were rejected just weren't piped into anything. So you can also fetch things on position. So if in your analysis, you are thinking to yourself, you have some form of nucleotide information of which you want to fetch, you can ask BAMQL to select all reads that have a nucleotide within a specified range. So for these, extension beyond your position can be returned. So if you're looking for something within a space, if your read extends beyond that position, you need to, if you don't want that, like if you want it to end at that position, you have to keep in mind that there will be reads that are extended beyond the position that you specify. And also, official mapping status of the read is ignored. So if you have a combination of mapped and unmapped reads within your file, your unmapped reads will also be located in your outputs. So you want to, you can combine other predicates in order to make this query a little bit more useful to your results, or you can just remove them before asking for them. And so here you can just ask for after, before, or within some form of range. Next. So this is an example of selecting range based on position. And here it just shows these two random positions on chromosome 1. And this is how many reads that it accepted and rejected. And here, if you have from some position after, before, it just pulls everything within that region. Next. So you can also search for specific sequences as well with this querying language. And so the sequence predicates receive, you can select whatever nucleotide within a specified region, and that would give you the amount of reads for that, and that will put it out into another BAM file. And so for the nucleotides accepted are your basic nucleotide values and also of your combination ones as well. And so they have these two different methods that you can use to ask for nucleotides. And this one is a degenerate match. And so those are for the ones that have multiple nucleotides within that value, then it can fetch all of those. And I'll show you guys an example of that as too. But for this one, unmapped reads and reads that do not contain that nucleotide at that position, those won't be selected. So here I just have a table showing the IUPAC nucleotide base codes. And so like here, these are the different nucleotide codes and what sort of bases that those can match for. And so for the degenerate matches, if you add these values here, if you have any of these combinations, it'll pull those out for you. But then if you ask for an exact match, so if you have a sequence alignment that has one of these values within that space, then it'll pull that one out for you. So you can also use these as an exact match if you know that information in advance. Next. So here I just had a couple of examples showing how you can select reads based on specificity with increasing specificity. So like here at this position, the nucleotide is a C, but So like if I ask for N, it will return any base. And for the B, which returns a CG or a T, then I still get those if any of those were there. But on here, for the Y, if it's a C or a T, I still get those reads. But if I ask for an exact match for the Y, then it's looking for a Y value in this space. And then they're saying that there aren't any there. So if you know in advance what sort of value it is that you're looking for, you could do the nucleotide exact search. And if you're not too sure, you can use the regular nucleotide search with one of the generic sequence nucleotide sections. Yes. So they also have a couple of miscellaneous predicates. And so these are just extra predicates that do not fall into any of the previous predicate qualities categories that I'm talking about, but these could be useful for BAMFA analysis. So here you can search with some regular expression in the headers of your reads, and you can ask them to pull those out for you if you have relevant information in those sections. You can also choose a sample of reads based on some random value. And so you can provide it with a probability, and it will just choose a random sample of reads. So if you want to do further testings and you wanted to have some random sample on which you want to do an analysis with, you can grab a section of that and do that as well. And this is just an example showing the random one, and it will just choose from your query sequences some random amount, and that random amount will be approximately whatever value it is that you put in there. Next. So one of the things that I was talking about was combining predicates, and you can do that using these logical connectives. And some of these might look pretty similar, I think familiar to you guys. So these are from the lowest to highest precedence of logical connectives. And so one of the things that I wanted to emphasize was this OR function. So in my experience, this OR is exactly 1, but they have this caret 1 here. So here, at least one expression needs to be true in order for it to return those reads. And in this version, exactly one expression has to be true. So don't be fooled. And there's also this if version. So like if you have some form of condition that you want, you can have that information, and of course the and the not. So this is just an example of using the logical connectives to subset a BAM file. And so like here, you can search for different things. So this here is just asking for some value within the chromosome name, and just to select 20% random stuff from it, and it'll pull that out for you. Go back. So they have another function that they call the BAMQL Chain. And this one was really awesome. And I was very happy for this function, and I was really glad that it was in here. And what it is that you can filter your BAM files through a chain of queries. And how this is different from the logical connectives is that the logical connectives save your output into one specified output file. But with the chain queries, it has multiple output files that are correspondent to each of the queries that you specify. And they have 3 different chain methods that they use for the querying. So the parallel chain is their default method. And what it is that they give each read to all queries. And so what that looks like is like if you have some reads and you have 3 queries, it's just going to give all of them to each query. And whichever read is in here, it's going to pull them out. Back. So for the series method, they give each read to each query in successful succession. So if you have, you want each read to be, it can only go to the next query if the previous query was a successful match. So like for this example, next, like it's just going to go one by one. And whenever it meets a non-successful query, it does not continue on throughout the queries until it reaches a match. So depending on what sort of question that you're asking, you're going to get different outputs. And then there's also the shuttle one, where a read is given to each following query if it failed the previous. And I think this is probably what most individuals will probably be using. Because like here for the shuttle chain, all it does is that it goes through each one and it separates them based on whether or not it is successfully in the previous query. And then if it's successful in the previous query, then it's attached to that one and it's not going to be in any of the others. So depending on how you can have the same queries, but whichever differing chain method that you choose, you can have different outputs. So that's also one of the things to keep in mind when you're trying to select. I see faces of confusion. Question. Okay.
So would the series chain perhaps be better drawn as putting arrows from query 1 to query 2? Because only if it passes query 1 does it go to query 2.
That is correct.
Okay, that would make it clearer.
So go like from here to here,
Yep.
rather than from here to here.
And you're each step you're narrowing down the set.
Yes.
You have most inclusive at 1. Only those that passed 1 and 2 are stored by 2.
Yeah.
1, 2, etc. So it's like a progressive filter.
That is correct. And this is just an example of what the chain filtering looks like. So for this section here, I had a couple of reads that were identified to different libraries, and I just asked them to pull out in each header to search for the library identifier, and then to stick those into BAM files containing that library itself. And it just popped out all of the different reads into their separate library files. So I had individual BAM files for each library, and that was really useful for downstream analysis.
Just a question. Does
Yes.
this start out with sorted indexed BAM files?
That is correct. Yes, they are sorted and indexed. They need to be sorted, but they don't necessarily have to be indexed. So there's you can tell it to ignore the index if you want to, and it will still work fine. So, but it does have to be sorted. So one of the things that they did was compare their BAMQL method to other methods used for analyzing BAM files. And next. So they wanted to see how efficient their querying language was in comparison with these other tools and languages. So what they did their comparison to was to SAM tools, this SoundBamba, to this PySam module in Python, and this Biosound Tools in Perl, and there's also this this library in C. And so they just did some comparisons with those to see how their methods hold up. So there is the all-powerful SAM tools. It is one of the basic analysis tools used for analyzing sequencing information, and it can do all of the stuff with high-throughput sequencing data. And it accepts these different sorts of alignment mapping files. And it also uses this HTS library internally. And like I said before, in most standard sequence analysis workflows, you're going to see and you're going to be using SAM tools. So of course, it did their comparison with that one. So there's this SoundBamba. I don't know if anyone has ever worked with this one. I have not. But this is a high-performance tool that is used to work with SAM and BAM files. It's pretty similar to SAM tools, and it's written in the D language. And I thought that was kind of cool. I hadn't heard of that before. So D comes after C, and it's kind of C-like. So that's why it's D. And so apparently this SoundBamba and SAM tools were in head-to-head combat for a couple of years until SAM tools caught up with parallelized BAM file reading. So they're kind of like on even ground now. So I don't know if anyone is familiar with this one, but that's where they stand right now. And PIFAM is a Python module that works with genomic data sets. And it uses a large array of high throughput data files. So you don't only need to use it to analyze your SAM files. So I thought that this was really awesome, and I probably will be using this in the future because since it does so much. It also wraps the HTS Library C API, and you can also access SAM tools and BCF tools with this module. So I was like, this is really cool. I'm glad that I got to find out about this so that I can use this in the future. And Biosound Tools is a Perl interface that uses the SAM tools library. So it doesn't do much in itself, but it is able to manipulate SAM and BAM files, and it's very similar to SAM tools, mostly because it uses the SAM tools library. So the HTS library is a C library that is used for reading and writing high throughput sequencing data. And it is used in many sequence analysis packages. So SAM tools, BCF tools, and PySAM uses this HTS library. And BAMQL itself also uses this library. So this seems to be the foundation upon which many of sequence analysis tools are built upon. And they just use this as is. So for their performance test, what they did was they had these triplicate runs on this workstation, and they used this 10 GB BAM file. And so this was an index sorted a male human whole exome sequence. And they made sure that from each implementation of the different packages, that all of the reads that were selected were identical. So there wasn't like any being left out on the side. And the tests were written as simply as possible without intentional optimization. So I'm guessing that when they were doing this, they just wrote it how an individual would write it straight out of the box, rather than using methods or different sorts of techniques to make it more optimized. And so for all of these packages and modules, they all ran 6 tests. So for the all test, all it was supposed to do was copy the input. And this is what they did to measure the baseline cost. So for the pair test, they wanted it to select all paired reads. And then for the chromosome Y test, they want to select reads on the chromosome Y. And so for the mitochondrial test, you're supposed to be able to select reads and their mate pair, if that mate pair exists, if it's unmapped or not on the mitochondrial genome. And then for the nucleotide test, to be able to select reads with a C at this position, and then also to do the chain analysis, where to just pull out all of the reads on each of these chromosomes and stick them in a file. So here they showed a couple of examples of the code that they wrote, and this one is for the reads located, for selecting reads located on chromosome Y. And people who are familiar will probably look at this and be like, what's going on here? I don't know why, but they said that they just they wrote them as simply as possible and without optimization. And I wasn't too sure that looking at this was exactly what that was supposed to be, but this is what they did. And
how comes Python code has no intel? How comes the Python code has no intel?
Yeah, so this is just what they had. You can go and you can download their files and you can play around with them if you want. They were pretty short though. I'll give them that.
Python code here doesn't need an intent given certain aspects of it. But aside from that, that's not PySam format, which is confusing.
I think they're just doing it in raw Python and not using PySam. Because they're just using a plain old Python regular expression.
Yeah.
So they're just it's raw Python.
For the chromosome Y version, because I also kind of talk about it on this slide. So here, I just highlighted the check marks that they had. So for the different sorts of codes that they wrote, they wanted to compare the filtering capabilities of the various tools. And so with the BAMQL, since this was all of the things that they had implemented in their tool, it of course has everything. But for some of the other ones, there were like missing dedicated filtering, or filtered reads by mapping were limited, and being able to filter reads by sequence were absent. So for those, they probably had to have switched to the base code in order to get their desired outputs.
By missing, does it mean that they are incapable of implementing it, or there's no way it could be implemented?
Previously not implicated in the version of these tools in which they did their tests, which would probably be most recent since this came out last year. So I'm pretty sure that if these individuals wanted to have these abilities in their tool, they can probably just sit down and whip it up and stick it in there and everything will be fine. But at the time of this testing, these tools either did not have this ability or was limited in its capacity.
Is Python in this case talking about PySam, or is it talking about raw Python?
It's talking about raw Python, but
for you could code those things.
Yeah.
So I don't know, is there any actual thing that you call a tool in Python, or did they just write that code?
I think they just wrote this code, and then for like actually going through the BAM file and pulling out some of the stuff, they probably use some of the PySam things to help with it, rather than just testing the PySam all by itself. Yes.
Looked like there were PySam objects though. If you go back to the code.
Yeah,
read.reference. Yeah, that's a PySam object.
And
So that's PySam.
read.reference.
Yeah.
Ignore case for read in file. If Y is a match. Yeah, there's probably some stuff in here for PyFam. But I haven't used it, so I'm not too sure. Yes. And so here is just a table showing their different results from their analyses, where the best performance is highlighted in bold. So BAMQL isn't always the best performer, but it did pretty okay in some of the versions. For example, system time seems to be consistently the best.
But
yeah.
usually you only care about the word time, right?
I'm sorry, repeat?
Why would someone care about the system time?
It depends on, I guess, what it is that they want. If you don't care about it, then you don't care about it. But then if you do care about it, then you do. So, so then if you want something with comparable system time, then
So
you'd want to do
for
that.
users expect you could only feel the difference in word time, and BAMQL is consistently the not the best.
They're just putting the response from the time command.
Yeah. Yeah. And they use a pretty large file too. Well, a good amount of information within their file. So yeah. So these are for the different tests that they had. So for example, selecting mitochondrial sequences, selecting the nucleotide sequences, selecting the paired end sequences, and doing the chain one. They didn't show the performance for the all test and for the Y test, but so this is what they had, and I thought it was good of them to show that they didn't do so well all the time. Ooh. So for the pros and cons, so some of the things that I want to talk about for this thing is I really enjoyed using it. I thought it was absolutely magical how I can just have these words and all the things that I wanted would come into my hands without me doing too much hard work. It was pretty easy to install on Docker, but if you aren't using a space where you have ultimate control, then it is a nightmare. And I could not do it. So I had to have IT install it on Flux for me so that I'll be able to use it on my work machine. They have a couple of specified distros in which when you go to their webpage to do the installation, and if you're working on those, it's like absolutely easy. And so like I just went on Docker and pull up an Ubuntu space, and I was able to get it running in like minutes. But like other than that, yeah, so I would say that was a con. I thought that it should be able to be usable anywhere and everywhere at all times, irregardless of your position in life on your workspace. The BAM analyses were really quick. So the files that I was working with weren't that large. So I'm like, for how you guys were talking about whether or not the amount of time used is really that relevant. Like my stuff was done in seconds, and I found that to be very useful for me, that I can just pretty much breathe through it. Yes.
Just clarifying, by analysis, you're using filtering and query.
Yes, just the filtering and the querying. Yeah. So just like in the future analyses, I had stuff that I wanted to do, but I didn't want to go through it and pull them out myself. So using the BAMQL to just say, give me this, give me that, and just have a whole list of BAM files that had the specific reads that I wanted each analysis to be performed on was very useful for me, and I thought that it saved a lot of time, both in filtering out and subsetting the BAM files and getting into the next step of future analyses. Yeah, and also you can do the multiple BAM file separations in chain. So I was using the chain function a lot to just parse it through and to just pull out a whole lot of the different sorts of reads that I had used. The documentation online was not that helpful. So I would say that that is a con, that if you were to look at it online, like I have it here and it looks so beautiful and easy, but that's because I had a bit of trial and error before I was able to become an adequate user. And in doing so, I was like, hey, this is really easy. Why did the online manual make it so difficult? So I guess it just depends on how you're able to accurately articulate the usage of your tool. And that is all. Questions, comments, concerns? Yes.
I'm going to be a little bit of a devil's advocate.
It's totally fine.
This is great if you're going to be filtering and querying, but if you actually plan on doing analysis of any of those reads, PySam is a terrific tool because it leverages the HTS lib. But furthermore, you can do lazy evaluation of those filters that or whatever queries you've applied to the sequence and do your analysis step by step on those reads in your script. You don't have to filter and then do your analysis later. You can just do it right there in time. So email. PySam is really powerful.
It is, yeah. Like I hadn't used it before until I read this paper and it told me about it. And then I went to look at it. I was like, hey, this is awesome. Why don't I know about this? So that's definitely a tool that I'm definitely going to be using in the future. But I probably will also use BAMQL as well because words. It's a good job. Anything else?
Do they have source code?
Hmm?
Do they have source code?
Yep. You can go on GitHub and.
If you have source code, why can't you just compile yourself and just install in Docker?
I don't want to.
I like the answer.
Anything else?
Any other questions? All right. Thank you.